Hello, in this short video I'm going to investigate the following problem. Let S be a set of cardinality n. How many commutative binary operations star can one define on S? Pause the video at this point and give it a try. Okay, so let us assume that S is this set of cardinality n. I want to define a binary operation on it, which is commutative. I want to see how many commutative binary operations I can define on S. What is a binary operation? A binary operation, a star, is just a function from the Cartesian product of S with itself into S. Okay, so the binary operations assigns one single element from this S to every ordered pair coming from this set. To visualize it, you can visualize it in this way. If I want to define a binary operation, I have to fill up every entry of this square containing n columns and n rows consisting of the elements of my set. That is the meaning of defining a binary operation in the first place. But this time I have one constraint. Because if I do not have any constraints, it means that I can fill up every square here with any one of these n elements. So to fill up this square, I have n options. To fill up this square, I have n options. To fill any square in this, I will have n options. But now I have one constraint. The constraint is that for every pair of x and y in S, I want to respect this commutativity relation that x star y is y star x. I want to consider that. Okay, so what is this constraint in this language if I translate it here? Okay, the one thing is that I can fill up these still with n options. Yes, I can choose any one of these elements and put them on the diagonal entries. Yes, so I have n options here, n options here, n options here, n options here. But one thing that is important here, for example, A2, still I have n options. But as soon as I choose what to put here, I have to choose the same element and put it here. Okay? Because I want to have the commutativity. Because what you put here is A1 star A2. What you put here is A2 star A1. But you want to respect this condition, so they have to be the same. So this means that I still have n options for this square, but as soon as I put any element of here, there, then I have to choose the same element here. So if I give this n option, then suddenly this becomes one option. And for example, let me say that this is A3, okay? So this is also n, this is also n. Let us say that this is A3. Still for this one I have n options, but as soon as I put n there, okay, I have to respect and put 1 here. That 1 means I have to choose the same element here, there. So if you analyze the problem, you see that on the main diagonal you will have only n. On the entries on the upper side of the main diagonal, you will still have n's everywhere, yes? But below n, below this main diagonal, you have 1's everywhere. So if I want to know how many options are available for me to define my binary operation, which is commutative, I have to, by product principle, I have to multiply all the numbers in this table. So the 1's are not important because at the end they will give me 1. So I have to count the number of n's involved in this table. So how many n's are there? Okay, so you see in total how many elements are there. This is n by n squared. So the size of the square is n squared. So it means there are n squared elements here. Okay, n of them. So how many of them are n's? Okay, so what should I do? You know, if I have n of them are n here, so I will say that I have n n's, yes, because I am multiplying these n's n times, and then I am multiplying the upper ends. How many upper ends are left? Okay, so how can I calculate that? So I would say that n squared is the total number of elements there. I take n out, it means that I took these n's out. There are n2 minus n non-diagonal terms left, but these non-diagonal terms are divided into two groups. One group has only 1 there, and the other group has only n there. So this means that I divide this by 2. So these n's are coming from multiplying the diagonal elements, and I will have other n's to consider, but how many n's are there? This number of terms. And don't worry about dividing by 2, because n squared minus n is always an even number. So the question mark is just multiplying all of them. The first one is simply n to power n, and the second one is n to power n squared minus n over 2. But I can combine them, so it becomes n to the power of n plus n squared minus n over 2. If I take the common denominator, it becomes n squared plus n divided by 2. So if you want, you can factor n out, and this will be the answer to this problem. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.